This problem talks about a computer disk, and it's starting from rest, so that means that omega naught equals 0. And it talks about how it has a certain diameter. Well, from the diameter, I'm going to take whatever that diameter is, I'm going to take half of that diameter and call it the radius. I'm also going to put the radius in the right units, which is meters. All right, so I'm going to have my radius in meters written down. And it says that it takes a certain amount of time, which they give you, to reach a certain angular velocity, which they also give you. But they give it to you in RPMs. You want this angular velocity to be in radians per second. So you're going to have to make that change, to change from RPMs to radians per second. And it says that the angular acceleration is constant. That means we can use our kinematics formulas, and we don't have to do calculus. And it tells you what the disk's moment of inertia is. So it gives you that, and it gives it to you in the right units, kilograms times meters squared. So they want to know for part A, what is the torque that's applied to the disk? Well, we have a couple of ways of calculating torque. Torque can be RF sine theta if we know the lever arm and the force. But they didn't tell us the lever arm and the force, so that's not it. Let's try the other one. The other torque formula we have is I alpha. Well, they gave us I, so this is probably what we're supposed to do. We've got the I and we need the alpha. And what they gave us was some stuff about omega. So that makes me think we are going to have to use those kinematics formulas. And my favorite one is omega equals omega naught plus alpha t, because I think it's the easiest because there's no squaring. Now look at what I have. I've got omega naught, I'm looking for alpha, and I have time. Hooray, this is what I get to use. So I'm going to cross out omega naught because that's 0. I find out that alpha is going to be equal to omega over t. I calculate that, and I can stick it into the torque formula, and I've got the torque. So that was easy. And now for part B, they want to know how many revolutions. Remember, the revolutions is theta. So we're going to have to find the theta. And the first equation I think of for finding theta is theta equals theta naught plus omega naught t plus 1/2 alpha t squared. Well, we can almost always make theta naught 0. And we know from way up here that omega naught is 0. So that means our alpha is going to be just 1/2. Our theta is 1/2 alpha t squared. Sorry. And we've just calculated alpha from part A. We have the t from way up here. The t comes from given at the beginning of the problem. And so we can calculate theta. When we calculate theta, it's going to come out in radians. So it's going to be some certain number of radians. You need to convert that to revolutions by dividing by 2 pi.